So today, I am going to present, actually give you a live demo of bringing up a full Vitess cluster in front of you. Not just bring up a full Vitess cluster, but actually go through the process of all the resharding that we are so proud about. And to make things more exciting, what I've done is I've stood up an app in front of the Vitess cluster that all of you can get onto and use you people to generate some load while I do all these maintenance operations, and we'll see if it survives. When I was testing it, I did see a few transient errors, so you may see those, but eventually things will go fine, I think. So we'll see how that goes. So that's basically the intent of this presentation. But I will give you a 5-minute intro of what Vitess is for those of you who don't know what it is. I am the co-creator of Vitess. I've been working on it since 2010 when we started the project at YouTube. Now, actually, after Vitess moved to CNCF, I have now started a company to provide commercial support for Vitess, which is PlanetScale. So what is Vitess? In very simple terms, it's basically a middleware for MySQL for sharding, but it can basically scale massively. You can essentially, there is no known limit to how far you can take Vitess. At least there are companies that have pushed it in all kinds of directions, millions of QPS, and Vitess has so far kept meeting their needs. And the other thing is, it is also highly available. You can comfortably get 5 nines of availability with Vitess. And more importantly, Vitess was built to live in the Google Cloud, Borg, and eventually those same abilities were ported for Kubernetes when Kubernetes was first released a few years ago. In some respect, Vitess was kind of a pioneer of being able to show the ability to run a stateful set under Kubernetes. As a matter of fact, the oldest Vitess instance has been running on Kubernetes for over 2 years now, as far as I can tell. That too at pretty high QPS, very high load, and has been a company called Stitch Labs. They were the first ones to do this. I think it was 2016 when they went into production, and they've been they are still on Kubernetes, as far as I can tell. So that's a quick background of what Vitess is. These are some of the stats. The coolest stat, in my opinion, is not how many people have adopted Vitess, but who is adopting Vitess. Like most of the renowned software companies have all either adopted Vitess or actually are evaluating it, which is pretty exciting. And this is not like a peripheral product that they are trying on. These are companies that are actually betting their business and relying on the fact that Vitess will not go down on them. These are the level of reliance on which, if Vitess went down on them, the company goes out of business kind of reliance. So that's a pretty heavy stamp of approval for us. Slack, for example, has about 20% migrated, and now they are accelerating their migration. So they will be getting to 100% very soon. How many of you were at KubeCon Shanghai? None of you, okay. Oh, you were in KubeCon Shanghai. JD.com is actually a huge company in China. They are kind of the Amazon of China, and they've been running Vitess at scale, at massive scale, over 10,000 VT tablets, and they were kind of the highlight of KubeCon when it was taken place in Shanghai. And all of you know Square, and a very interesting tidbit is this is a very recent tweet by Mr. Jack himself. As you can see, the Square's Cash app made it to the top charts in iOS and Android, and the Cash app now fully runs on Vitess. When they first migrated their unsharded database to Vitess and then sharded Vitess underneath. From what I hear is they are growing so fast that they are sharding every week, is what I'm hearing. So if you can see here, the top app uses Vitess. The second app also uses Vitess, and the Cache Apps engineer keeps bugging me, saying that we have now taken the creator of Vitess, because YouTube was the creator of Vitess. So we are going after Burger King next. So, yes. All right. So this is kind of the community that that Vitess has. Actually, it's a lot bigger than this. These are the people we have permissions from to use their logos. If you look at, if you join into Slack, you will see bustling activity. You can check out people from all kinds of big companies migrating to Vitess. And not only migrating from MySQL to Vitess, there are people migrating from Mongo to Vitess, Cassandra to Vitess. So we are beginning to see something that I have not seen before, which is uncomfortably exciting is the word I would talk about. So it's like, we'll see how things go. This is the high level. So the rest few slides, I'll gloss them over very quickly because I want to get to the demo and give myself enough time for it. This is the high level architecture of Vitess. The takeaway from this architecture is that on the left hand side, the app servers connect to this proxy called VTGate. And they don't care about what is behind VTGate. They just treat VTGate as if it's a giant database. VTGate speaks the MySQL protocol. So you connect to VTGate as if you're connecting to a MySQL server and just issue queries, and VTGate will figure out how to fetch the data for you. And behind the scenes, there is a log server that is used internally by Vitess for discovery and for management. So this is a very fast and quick overview of how Vitess does what it does. This is a kind of the view that you get, is that once you have written your app server to use Vitess, then you mostly don't have to change it while you do things underneath to the database. For example, you add replicas, then Vitess will automatically load balance against them. The demo that I'm going to show is going to go through these workflows. Hopefully we'll get to the end before time runs out. So the first thing usually you do when you run into scalability issues is split your database into smaller parts. You basically take a few tables, move them out into a separate database. So that's the first thing that you get help with. Vitess will do that migration for you without affecting the application, as I said before. And then, but this type of approach goes only so far, because eventually some of your tables are going to get too big and you have to shard them. So that's your only option. And when that time comes, Vitess can help you do the sharding and keep scaling as your app grows. And eventually, you can deploy Vitess into multiple zones throughout your world and basically have a worldwide deployment. And still, as far as the application server, it is still talking to the same database, except it's now huge and giant. So the demo that I'm going to show is a very classic use case. It's a commerce application where there are products and customers come and place orders. You start off with a single database, all these three tables being in a single database. The first thing that we are going to do is move customer and order into a separate unsharded database while the site is still continuing to serve traffic. And after that, what we are going to do is reshard the customer database into multiple shards. And while, again, all of you keep generating load into the application that I have written, as an engineer has written. You will see it when you see the UI, that it was not a design person who wrote it. All right, so let's get to the demo. So before I jump into the demo, I will show you what I'm going to do. So if you go to the Vitess website and go to examples/helm, you will see a bunch of YAML files. They are all numbered. So if you launch Minikube and execute these YAML files one after another, that's essentially what I'm going to do the demo. And these files actually give you the full sequence that I'm going to show here. But I have changed, so these YAML files are tuned to run on Minikube. I have made some modifications to that to those files so that they can run a real Kubernetes instance, like how you export the service and how you use the resources and stuff. So they are more expanded. And the instructions for this are in the vitess.io website, the brand new website that we have built for 3.0. And you can follow these instructions right here under tutorials. Okay, so for the sake of time, I have already done the first launch. As you can see, let me scroll back. Is the text visible? Should I make it a little bigger? I think I'll make it slightly bigger. All right. So if you scroll back up, what I did was I did a Helm install of the first script, which is 101, which is script 101. So what the script has done is actually brought up my cluster, which I can show you here. You can see a few pods that have come up, and you'll also see about 10 pods for the commerce application. Actually, it's better to show them here. When I get jobs and pods, you see there are 10 application pods. They are stateless. They just redirect, convert your request into queries. And there are 3 global HCD instances. There is 1 HCD instance per zone. There's an HCD operator, which I use. And there are those components that I showed you in the architecture diagram. The 3 VT tablets are the commerce VT tablets. So if you go to the Vitess console, it might have logged me out. Let's see if it allows me. Yes, it didn't log me out. Okay, so you can see that there's a commerce database. If you look at the schema for the database, there's order, customer, and product. Order is called C order because order is a database keyword, SQL keyword, so it does not like such names. I mean, you can make it use such names, but it's very inconvenient because you have to keep escaping it. I will show you the YAML file for this. Here's the YAML file. So so I'm using Helm charts to show this demo. What the Helm charts have done is actually abstracted all the pods and stuff away, but then given you the ability to talk the Vitess language. You can see here, I have something called a topology. I have cells. So these are elements of Vitess. And I have created one key space, which is my commerce key space. And I say there is only one shard because this is an unsharded key space. There are a few replicas that I've specified. And my schema, I've given it right in line here. You can see the 3 tables, product, customer, and C order. I've also defined a V schema. A V schema is also a Vitess schema, or another way to say it is basically your sharding schema. It tells Vitess how the database is sharded underneath. And that's what Vitess uses to abstract the details of sharding away from the application. So far, so good. And once this is executed, all those pods came up and magically. So I could even I even have a MySQL. So this is my MySQL script. I can do things like show tables, select star from user, customer. It's empty. So now I'm going to reveal my website to you, my e-commerce website. It's called PlanetScaleLabs.com. So you are welcome to go there. Please don't try to buffer overflow me. It'll probably break, but as long as you give reasonable inputs, it should behave fine. I'm going to start off by entering myself as customer. I am customer ID number 1, and feel free to start creating. What I've done is these tables will show the last 20 rows that were created because I don't know how aggressive you're going to get about inserting rows because you could do enter, enter, enter and create lots of rows. Looks like some people have started creating their customer. So ideally, a good application will enforce relationships, which means that if you enter a SKU, it has to make sure that there is a product with that SKU in it. This one does not because I didn't have the time to do that, and it's not really necessary for this demo. But as I go through the demo, you're welcome to keep hitting this application and generating load. So the next thing I'm going to do is split this database into two, because we want to do the resharding. So we are going to move the customer and C order table out of commerce into a separate customer database. And the way to do that are through the subsequent scripts, which is, so the way you do this is by issuing upgrade commands. Oops. And the first upgrade command that you issue is 201, which is the next one. So the first step I'm going to do is say that I'm going to create a key space called customer. So it's an empty key space, it's just a placeholder. If you actually went and saw into the dashboard, customer has shown up here as a key space, but it has no shards, it has nothing. The next thing I'm going to do is create one shard for that customer, and also make it do some aliasing. So what we are going to do is the customer key space is going to be created. We are going to add tables, the customer and order tables to that key space, but when the application sends queries, they are still going to go to commerce, which is the place where the original tables are. So when that happens, what we are going to do is under the covers, we are going to copy the contents of customer and order into the customer database and set up continuous replication from commerce to customer. So once the replication has fully caught up, we can then say, just cut over the traffic from one to the other, and hopefully the application should see no change at all. So I have to see, these pods take a while to come up. Let's see if they have come up. They are coming up. It's 4 of 6. It should go to 6 of 6 when it is done. And in the meantime, I will show you what the Vitess console shows. It says that now customer has one shard, which is shard 0. 0 usually means unsharded, but you can also mark it as sharded. So it allows us to go back and forth in terms of testing. And these are the, I'm basically having 3, 1 master and 2 replicas as a setup for this. Let's see if our shard has come up. It's mostly come up. I think the next step should work. Let's see. So the next step is to say, start this process of resharding, which is do a vertical split. I will show you what the command is while it executes. If you look at the vertical, let me see, how is the load going? Have you all been doing load generation? Ooh, all right. 59 and 244. Awesome. Okay. So when I do the vertical split, I'll show you the command here. Create key space. So here I'm saying that perform a vertical split clone, which means that clone the customer and order tables from the customer, from the commerce into customer. So this is the command. And once I issue this command, it should hopefully finish soon. Let's see what it has done. So that job, okay, it says VT worker vertical split is successful, which means that it has finished the clone, it has done the copy, and it is now doing replication. So as you insert rows, all those rows are actually being copied into the customer database. Now I'm going to start doing the cutover. So the cutover is 204 vertical migrate replicas. So the cutover is done one step at a time. So remember, these are things that you do with hundreds of terabytes of data. So all these steps are things that happen over a period of many days. So I'm just crunching them all within a few minutes. So at this point, I'm saying the traffic is being cut over. All the replica traffic now is being moved over to customer. And I can show you using MySQL. Actually, it'll be a cool thing. Let's see if we can do that. Use customer use customer at master. So if I say use customer as master, I'm going to do a count star. I don't know how many rows you've inserted. From customer. This query is going to go to the master. But if I say use customer at replica, this query is going to go to the customer database, 77. So the replication is still happening. And now I'm going to do the final cutover, which is move over the traffic of the master to customer, which is 205. It has been done. Did any of you see any errors? No? You did? When you created the customer shard, right? Yeah, that should not happen. So we should file a bug and do that. No one has complained about it. So it's still working. Are you still able to submit data? All right. So what we have done is now that if you now go look at the database here in the dashboard, you will see that commerce still has customer and product, but you cannot write to it anymore. But customer has also customer and order, but you can write to, all your writes are now going to customer and order. And at this point, I can go delete the tables from commerce because they are not useful anymore, which is what this cleanup step does, which is 206. I will show you the step in 206. You can see drop table customer and drop table order. They have been dropped.
Is productivity a foreign key that still is validated, or was it never a foreign key?
So these are logical foreign keys. These are to be enforced by the application. So Vitess assists you but doesn't enforce it. There is a big debate about foreign keys because many people shun it. There are some good aspects of foreign key, some bad aspects of foreign key. Vitess exposes the good ones, at least what we believe are the good ones, which is the efficiency of reusing indexes when there is a foreign key relationship. But enforcing a foreign key potentially is very expensive. Therefore, Vitess doesn't enforce them. It relies on the application to do it. So, 670. It's interesting. Okay, we'll see. We'll see. I have a magic number that you should not exceed. If you do, I have to go hack my scripts.
That's over 1,000 now.
Yeah. Oh, okay. Okay. I won't reveal the number because you will hit it. Okay. So the next step is, so this is kind of an easy part. This is something that you could brute force manually. Moving tables from one database to another, you can kind of brute force it using some kind of MySQL filtered replication. But the next step is to reshard the customer database, split those tables into smaller parts. So for that, what we are going to do, the first step, step itself is a problem because if you saw those tables, they have MySQL auto increments. How is auto increment going to work in a sharded environment where tables are spread across multiple shards? So it doesn't work. So what we did in Vitess was provide an equivalent feature using a sequence table that issues monotonically increasing numbers. So we are going to do that step, which is basically migrate from MySQL's auto increment to using Vitess's sequence tables. So that is this YAML. And I should have checked the number. Let's see. Uh-oh. 1,000. Oh, it is 1,000. Let's see. Let's see. No, 1,000 is where it went. Somebody insert something. 10,000. Okay. So yeah, I was worried that you will hit over 1,000, so I made it 10,000. So yeah, so I started the sequence off at 10,000 so that there are no overlaps. And now if you actually, you can see that it is now counting up from 10,000. But these rows currently are still going to an unsharded database. But we are going to split it and it will continue to behave the same way. So the next, now that there is an interesting thing that I want to show in the YAML here is now the sharded V schema is not a simple JSON anymore. It is a lot more complex because we are now expressing a very complex deployment scheme to Vitess. We are saying that these tables are sharded. This customer table is sharded. Vitess does not believe in the word sharding key, even though we use it. We like to call it the primary index because we are a database system. It's kind of like a primary key, but it is a primary sharding key. But then the primary index is capable. The best part of the primary of a index is that you can provide custom functions for it. And the other cool thing that we have done is in the customer table, I've said the customer ID is your primary index. In the order table, it's again customer ID, which is the primary index. Even though order ID is the primary key for order, the customer ID is the sharding key for order. So what that gives me is to co-locate rows of a customer's orders with the customer itself, which means that when I do a join between customer and order, it will be a single shard query. That entire join will be sent down to one shard. If you have transactions that affect both customer and order, they will also be single shard transactions and therefore efficiently executed. So this is something that I will try to show you an example data later about whatever you created ended up in different shards and with rows that are related still living together. All right, so this is now applied, should be applied. I'm not going to check, I'm going to assume optimistically that it is done. I am now going to fire up the shards. This takes a while because 6 pods need to come up, and those pods need to create MySQL instances and initialize them. So let's see. You will see a lot of inits that are. So what I'm now doing is actually the way you reshard in Vitess is you don't touch the original shard. The original shard remains as it is. You create brand new shards, which are your target shards, into which Vitess is going to move data. And the way it does it is by splitting. So when it's again 2-step process. When you do a split clone, is basically copies the data, divides them into 2 or 3 or n, any number that you want, and then copies different portions to the different targets. Once they are all copied, it sets up replication from source to all those destinations, but in a filtered fashion. It will only send the row that was affected to the shard that it belongs to. And this is again very similar to vertical split, but it happens for resharding. Also, Vitess can do merge shards. If you think that your shards have become too thin, you can also merge them back. So let's see if they are running. It looks like it's almost ready, 4 of 6. And let me see if I can show you the YAML for that. You can see the YAML keeps growing and shrinking depending on what we do. So the cool thing about this Helm chart is you can create jobs, and then in the next YAML you delete that job, you create a new one. It will also cause the old job to go away. So it keeps your Kubernetes instance pretty clean. So you can see that some of the jobs that I launched earlier are not there anymore, like those vertical splits and horizontal splits. They don't exist anymore. Let's see where we stand. Okay, we are all ready to do the sharding. How are we doing on the load test? This is when you should pound the database. Okay, I'm ready to start the sharding. The first step is actually non-intrusive because I'm just going to do the split clone. It's going to copy all the data in the background while it is there. So there is nothing affected. There is no cutover or anything. So let's see how long that process takes. Oh, it's already done. And let's then start migrating. Let's do 304. Replica traffic is migrated. And let's see if it is done. It is quickly done. All right, so now if you migrate, you may see some errors because we are now going to move from shard 0 to shards -80 and 80-. So if you ask why 80 and why not 50, it's because we are hexadecimal. 8 is the middle for hexadecimal. 1, 2, 3. Okay, go. Did it survive? Yes, it did. 10,018. Okay, so now if you let's do some verification, some random verifications. So select customer ID from customer limit 1. I don't know if this will work. Let's see. 4. Okay. So select customer ID, comma name, comma SKU, let's say, from customer, join product. It will probably complain on customer customer dot. I should alias these. C. Hold on. Sorry. So C dot customer ID. I'll tell you why I have to alias them. C dot name. Actually, let's do C dot name, comma C dot SKU, O dot Q, SKU from customer C join order O on C order, yes, C order O on C dot customer ID equal to O dot customer ID. Oops. Whoa! 1672 rows. Somebody placed a lot of orders. So this is actually was a single shard query. So Vitess knows that these customer and order rows live together and sent that query to just that one shard. So you can just so that's the cool thing about Vitess. You can just bring up Vitess and then bring up a MySQL console, connect to it, and start issuing random queries like this. Cool. All right. And then after this, there are a few more steps that you perform to finally clean up. You have to go delete shard 0 and get rid of all the old artifacts, which I am not going to do right now. Instead, I am going to conclude this session with a few advertisements. As you know, the talk was supposed to be given by me and Dan Kozlowski, who is sitting here. But we decided that I will give this talk today and he will do the deep dive tomorrow. Tomorrow he's going to show you how to play whack-a-mole with pods, with Vitess pods. Just bring up a bunch of pods and start killing them and see if Vitess survives, which is basically the most important requirement for a stateful system to live in the cloud. So that is going to be tomorrow. And HubSpot is actually also one of the oldest users of Vitess. They've been using Vitess for over a year now. And they were the first ones to develop a Kubernetes operator for Vitess. And so they will be presenting this on Thursday. Slack channel is very friendly and bustling with activity. So you're welcome to join it. And feel free to try your class. So the Vitess, you can bring it up either in Kubernetes or outside Kubernetes. You can just bring up a raw Vitess cluster in your laptop. There are instructions for that also. So that's it for now. If you have any questions. Yes? So the speed of loading data, the question is what's the speed of loading data into the cluster? It is as fast as MySQL can handle it. And which essentially means there is no limit to how fast we can ingest data. It's basically how wide can you shard. So typically, I have seen that a single MySQL instance can ingest about 3,000 insert statements per second. If you actually group those inserts into single statements, it does go much faster. But since there is no limit on the number of shards, there is essentially no limit. So we are running some benchmark tests with our customers, and we are seeing like 200,000 QPS of inserts, and that is just basically on the hardware that we have provisioned. If you provision more, you can do more. So there is essentially no limit to how much you can ingest with Vitess. So the load data local in file is a feature that is being worked on. There is actually a pull request that I have held off on because I've told them that they need to write tests. That is one thing that we really insist on with Vitess, because the way Vitess works is we push code today in production. Tomorrow Slack is going to import that and push it. We submit code into GitHub today on master. Then 3 days later, Slack pulls that code and deploys it on their production. So we are very insistent that whatever feature you write will work and has all the tests that are required. And it's the case with almost every Vitess user today. YouTube also, within a week of getting submitted, gets pulled into YouTube and goes into production. So, and sometimes they say, why don't you have more releases? We don't, like, every one of our submits to master is a release. So that's how we've been operating. Yes?
Can this run outside of Kubernetes, like on raw hardware?
Yes. Vitess can run on any platform, essentially. It runs on-prem in raw platform. It runs on Slack uses it on AWS, but not with Kubernetes. They run it on their EC2 instances. It even runs on Mesos. It runs on what else? Yes, it is very customizable and it can run on any hardware.
Is there like a documentation on Vita?
Yes, I recently created a VT tablet modes section in Vitess, which actually tells you how to make Vitess, how to point Vitess at an existing MySQL instance. You can just, it's a middleware, right? So you can bring up Vitess and say, here is the MySQL, serve traffic, and then you can go back and forth. You can send traffic to MySQL directly, or you can send it through Vitess, and you can that way slowly migrate if you already have a working MySQL instance.
So kind of going off of that, I noticed that the MySQL Server version was 5.5. Is that a requirement?
Oh, where does it say 5.5?
It was when you were doing the demo of the
Oh, that's a lie. That's that's Vitess claiming to be 5.5. It's a number that we have hard-coded. In fact, I don't think we support 5.5 really. We support 5.6, 5.7, 8.0, MariaDB, 10.x, all MariaDB versions. Yes, it's probably 5.5 because MariaDB 10.0.1 was based on 5.5, and we hard-coded it as 5.5. There is a bug out there that we have been procrastinating on, saying that Vitess should actually publish a more meaningful version number. Right now, only MySQL and their derivatives. Vitess can run on RDS. It can run on RDS Aurora. It can shard RDS Aurora if you choose to do so. There have been many inquiries about Postgres. And we are beginning to think about what we can do to make it work with Postgres. One more question?
Replication across different data centers.
That's a very good question. Whether replication is supported across data centers and regions? Absolutely. Vitess does not care. You can, we have demos that actually show this ability. We have demos that show replicating from one cloud to another, demos that show replication from a cloud to a non-cloud. As long as the right pipelines are set and security is enforced, replication works from anything to anything. The replication can be bidirectional. What I mean by bidirectional is that if you have a cluster that have many masters, you could have one master in one cloud replicating to replicas in another cloud, and a different master in the other cloud replicating the other way. Replication otherwise for a single shard is unidirectional. It goes from the master to a replica. But you can fail over the master from one cloud to another, in which case the replication will immediately be reversed by Vitess, because it will start pushing data in the other way around. Yes.
So in a multi-cloud setup like that, do you run like the American both clouds? Is that how that works?
In the case of a multi-cloud center, the thing that we have to do is make the log server globally accessible by both parts. And once that is possible, once that is achieved, then these different clusters can talk to each other because the log server gives you, tells you what is where. So that's essentially how we achieve multi-cloud. Yes?
How does this work with GitHub's Orchestrator?
Oh, so yes, we actually, the question is how does it work with GitHub's Orchestrator? We actually approached Shlomi, who is the author of Orchestrator, pretty early on to integrate with that. So actually the reparent story for Vitess on a master going down, unplanned failure of a master is actually handled by the orchestrator. So you can set up special variables in the orchestrator where orchestrator will perform the failover and tell Vitess, I have now reparented, here's your new master.
That takes like 90% of the job away.
Oh, so he's going to do that. So he's going to give you the orchestrator demo. Shlomi is a very good friend of Vitess. GitHub is also evaluating and in the process of adopting Vitess. So we are actually collaborating very closely with them. The Ghost, there is also integration with Ghost, which is another tool that Shlomi wrote. Yes? That's a very good question. So what is the latency overhead of Vitess? It is around 2 milliseconds per hop. It's basically 2 hops, so it is 1 millisecond per hop. It's a very conservative estimate. People have observed lower latencies, but if you are planning, you have to kind of assume that every one of your queries, there's going to be this 2 millisecond additional overhead. At least at a high level planning, it's good to keep that in mind. There are ways to actually reduce that latency if you really, really want it. There are some trade-offs we can make, and we have done that for a few people. But the default way Vitess operates gives you a 2 millisecond latency. All right. Thank you very much.